Good evening to you all. I would like to warmly welcome you to today's session, Sustainable Approach of Textile Chemicals or Apparel Industry. This webinar is organized by the Moratuwa University Textile Association, widely known as MUTA. Let me introduce the MUTA. Its membership consists of the staff members, graduates and undergraduates of the Department of Textile and Apparel Engineering of University of Moratuwa. This session is on live using MUTA YouTube channel and Facebook, but the YouTube channel can be displayed only for members. One of the key objectives of MUTA is to widen the interest and associated knowledge of the members in the field of textile and apparel related areas. Also, the association acts to enhance the social interaction and welfare of the members. To fulfill the above objectives, we plan to conduct a series of webinars and also to launch an e-magazine to share knowledge and industry trends related to textile and apparel industry. I believe that all the members and practitioners will be benefited through both of these activities. Today, Mr. Dinusha Somasiri is the moderator of the event. Let me introduce Mr. Somasiri first. He is an excellent product of the department and he was graduated in 2009. Currently, he is working at Hayleys Fabrics Pvt Ltd as a head of innovation and development. He has 12 years of experience in both apparel and textile sector. Today's presenter, Mr. Dayantha De Silva, will be introduced by Mr. Dinusha. Over to you, Mr. Dinusha.
Right. Good evening to everyone. So we have a very wide audience today, starting from university students, textile professionals and chemical professionals as well, and even including university lecturers and senior lecturers, and few people who's interested regarding the chemical industry of textile and clothing industry. So to speak few words about today's speaker, I would say he is a valuable asset to the whole textile and apparel industry of Sri Lanka. His passion is towards chemistry, so he completed his bachelor's degree in chemistry and he completed 2 postgraduates in polymer science and polymer technology. But that's not the important point here. But most important point is he was brave enough to start his own chemical manufacturing plant to compete with all the European chemical manufacturers in Sri Lanka, and after, in 1998. And today his company is the only textile chemical manufacturing company in Sri Lanka, and he is today competing with all the European chemical manufacturers, and most of the time the industry is getting a better service than all of the European chemical suppliers for the industry. And he is none other than Mr. Dayantha De Silva, Managing Director of D Chemicals Pvt Ltd. And without further ado, I'll hand over in the session to start the presentation. If you guys have any questions regarding the presentation, please type that in the chat and we will read it out after the presentation. We have a specific Q&A session for that. Mr. Dayantha, session is yours. You can take it over.
Good evening to everybody. Thank you, Dinusha. Today's topic, what we are going to discuss, sustainable approach for textile chemicals for apparel and fashion industry. First of all, we have to understand why we are going to have a sustainable approach towards whatever the manufacturing processes or any new developments for the fashion well as for the apparel industry. The history of textiles is almost as old as that of human civilization. With progressive eras of and civilizations, the history of textiles further enriched itself. If we go back to old records, we can find out far back as Neolithic era, indication of using flax and certain wool fabrics at that time. In India, the culture of silk was introduced in 400 AD, while spinning of cotton traces back to 3000 before Christ. That old industry, but evolved so rapidly, and now we are in this situation. In 17th century in Europe, actually revolutionary developments like flying shuttle, spinny jenny, water frame transformations happened, and at the same time, chemical bleaching and dyeing of fibers and little bit of printing also evolved. If these same premises, dyeing, pre-treatment, and finishing happens, the mill concepts foundation also laid. At that time, only the mill concept came into the apparel industry. With this mills concept, the entire world's economic parameters and social measurements change a lot. Because of the mills, a lot of economic growth and urbanization also happen. In the meantime, because of the economic growth, a lot of mills also coming into the picture, and then only the problem started, because whatever the discharges goes to the waterways well as for the atmosphere, lot of emissions and discharges, well as due to urbanizations, the population density starts health issues and social problems. Then relative authorities at that time, the governments, monitoring bodies, and pressure groups started to consider this industry to keep it a controlled manner and sustainable approach. This is how the sustainability come into the textile chemicals. The easiest way for sustainability is under Stone Age approach, limited resources and minimal usage. But with the modern developments, this is an impossible task. And then we have to think about sustainable development for the industry. Chemical industry especially, we have only limited resources and we have to manage it properly with social well-being. Without harming to the environment, we have to address for the health issues, then only the sustainable development comes from the textile auxiliary industry. Whatever practices in the old age, now the current trend and the current development and current parameters, we have to give a lot of thoughts to achieve the targets or the parameters. Man-made and the natural fibers, we have to do a lot of processes like weaving, knitting, pre-treatment, dyeing, finishing. And for the man-made fibers, the polymeric synthesis and conversion into fibers, a lot of chemical actions has to carry. With you can see in the screen so many chemical categories involved in this. I don't want to discuss each and every category. There are so much of intermediate products and the auxiliaries involved in today's chemical industry. Polymeric products, amines, condensates, oxidizers, reduction compounds. Now at the moment, even the viro blocks and virology related auxiliaries. All these things, again, you can categorize into different categories because the auxiliaries handled in different departments in a textile industry, well as wet processing industry to generate a fabric or a garment. Whatever the chemical applications, after the application, all these things will go to the wastewater, dumping into waterways, vast amounts of harmful chemicals can be byproducts of textile industry. From these harmful chemicals, key concerns acidification, eutrophication, aquatic ecotoxicity. From the burning gases or other emissions, also a lot of pollutants released to the atmosphere, including nitrous oxide, sulfur dioxides, and carbon dioxide, carbon monoxide, and all these things will give concerns for global warming, ozone depletion, human toxicity, and summer smoke. Now, we all know that summer smoke is a huge problem in most of the textile-related cities, like New Delhi or Beijing. Now, it's unavoidable level. Summer smoke creates problems. A lot of pressure groups and government authorities talk about how to minimize the impact from the growing industry. Ultimately, it's an ongoing discussion, and Greenpeace, as a pressure group, challenges Adidas and Nike July 2011 to create a detox campaign. They displayed banners in front of the biggest warehouses and showrooms in Nike and Adidas in China. But not only that, for the other leading brands, a lot of pressure applied. Levi's, Inditex, all these people got the maximum pressure from pressure groups, how to control this rapid growth without disturbing the environment. Then most of the brands decided to keep certain unwanted or restricted substances which will harmful to the human beings well as to the environment to avoid in their apparels and garments. Inditex initially, they defined 5 classes, and all the other leading brands also like M&S, Levi's, Victoria's Secret, VF, they defined their own restricted substance list. Then only the huge challenge comes to the chemical auxiliary manufacturers, how to avoid these substances on their fabrics and garments. The auxiliaries will create these unwanted substances into the fabric. Because of that, we have to control our synthesis and the end product, our ready-to-use product supplied to the fabric manufacturer or the garment wet processing plants. A lot of back calculations and rethinking to give new chemistries sometimes, but all the time you don't need to rethink. With the old chemistries also, with a lot of control mechanisms, we achieved to fulfill and comply these RSLs. But for ongoing tasks, for new developments, for the chemical auxiliary manufacturer also has to think of product ideas. When it comes to the product idea, always you have to think about a product life cycle assessment. Selecting building blocks or the raw material, in the sense intermediates or initial raw materials, go through the raw material data investigation, or then go to the RSL evaluation, restricted substance list evaluation, by analyzing the raw material well as intermediate product analysis, creating any restricted substance. From the other hand, the whatever processes, you have to do a safety evaluation. The reactions will give harmful emissions or discharges, exothermic reactions, uncontrollable levels, or it's a fair reaction to the factory level. Hazard analysis report also goes to the product identification level. This hazard analysis is another level of giving assessments to the human toxicity and environmental toxicity, starting from mutagenicity to genotoxicity, to skin eye irritation to corrosivity. All these parameters, we can get the basic information from the raw materials. And sorry. This carcinogenity to skin irritation and corrosivity or all the parameters, you can get it from basic raw material information, especially from the material data sheet, material safety data sheets. You can get all the information. And the most important thing, with those discharges, the persistence in the discharging areas, bioaccumulation, biodegradation, aquatic toxicity, ozone depletion, and greenhouse effect. All these parameters we have to properly analyze and get a measurement before you go to the product idea. Then another very important thing, how to make your resources. I will give a good example. Carbon chain for surfactants or fatty acid derivatives, you can derive it from the petroleum cracking. That is from carbon 10 to carbon 20. You can get it from petroleum cracking or from the plant-based oils like palm oil, castor oil, soybean oil, or sugarcane. You can get these carbon chain derivatives. Then convert into a right intermediate product. And if you get it from the plant base, definitely it is a more sustainable and environmental friendly raw material sourcing. The products and the manufacturing is close by to your final plant. The transportation is also give a huge impact because you can reduce your carbon footprint very much if you are processing plants, everything together. In 19th century and 20th century early, the European certain corners, textile corners, everything is happening in that particular area, and a lot of energy and time saving at that time from those areas. Now Asia, we try to do the same thing to avoid the carbon footprint damage. Now the chemical manufacturer is having a huge task compared to the textile mill or wet processing plant, because in manufacturing of the auxiliaries, we have to control our reactions with minimum impact to the environment, well as lowest emissions. And there is an additional task for us to give the mill with a sustainable solution. Less energy, less water, and minimum disposal tasks for treatment plants, like minimum BODs, minimum CODs, and all that. Because of that, additional tasks and manufacturing risk, chemical auxiliary manufacturing is the biggest sustainable risk factor involved party in this cycle. Packaging also, if you are using a recyclable or some environmental friendly packaging, it helps for the carbon footprint. Now again, exposure assessment also I will go through quickly. Environmental exposure, air emissions or water emissions, and workers' exposure for health issues, undiluted auxiliary, how it react with human skin or with whatever the health issues. Consumer exposure is the most important thing. That is again with a lot of studies with RSLs, but again we have to recheck dermal, oral, and inhalative. I'll give a very good example. Now, these days, a lot of antibacterial and antiviral products are, it's a challenge for every auxiliary manufacturer, but a lot of health issues like nanoparticles or certain metal parts, it's not good for the health. Still on ongoing discussions. Because of that, for a auxiliary manufacturer, it's a huge upcoming task because there is no definition for those things at the moment. If you do a wrong thing, another 10 years time also only the repercussions and the social impact comes in with those products. Now, the approach by the textile industry for sustainability, there are three ways: regional approaches, individual buyers approach, and third-party certification bodies. I already discussed about the individual buyers approach because Inditex, Mark and Spencer, all these leading brands, they define their RSLs and they have their own way of controlling the restricted substances and the emissions. Regional approach, Europe, it's a good example that REACH restricted substance list. In Europe, you have to manufacture all the substances according to the REACH guidelines. If you are manufacturing outside Europe and export to Europe, you have to follow the REACH compliance list. The third-party certification is a now most effective controlling system. Blue Science, Cradle to Cradle, Organic Cotton, that GOTS, Green Streets, Cavira, and all these people having their own platforms. Ecotex. Out of that, I think Blue Science, they are not only control the emissions and restricted substances, they are work as a system partner to monitoring the manufacturing parameters and emissions, social impacts, and all that. Cradle to Cradle also having fairly a good system. Material health category, they divided the system into 5. Material health category, material reutilization, renewable energy and carbon management, water stewardship, and social fairness. All these above categories, evaluation process is very strict, and after the evaluation, they offered a point system. According to the points, manufacturers' products can be categorized in the basic level or bronze, silver, gold, or platinum. There are so many now monitoring bodies, and it's become a complicated story now. Because of that, everybody talk about how to link together. Because for chemical manufacturers, well as the end users in the mills or processing plants, they are also confused to a certain extent because different brands and different pressure groups, they define different monitoring bodies. Then everybody talks the similar language. Ultimately, the zero discharge platform, zero discharge hazards chemical contributors platform came to the picture. S&D Chemicals also one of the initial contributor for this platform. And this platform, there are 4 levels. Level 0 is a supplier declaration only. But level 1, you can declare your material data sheet with all the necessary toxic data and other data. Then the product will come to the level 1. Then the level 2, the product stewardship. The product 3, level 3 is the chemical evaluation and actually do a chemical supplier visit also from the zero discharge people. You can see how we performed in the zero discharge gateway. This is a common platform for most of the other monitoring bodies. I think from 2022, this will be more effective and everybody can see a common platform for RSL evaluations and the emission controls. Now, every chemical manufacturer should have a product stewardship and input control system, because most of the raw materials, if you are not getting from a regular and reliable source, you have to initiate to analyze RSLs, restricted substances, well as after the reactions, what sort of residuals and emissions during the process. Then formulates products within the limits of restricted substances, keep raw material, intermediate and product data. This product data includes this hazard analysis also. That means all this carcinogenic data up to skin irritation and all these other parameters also should submit for raw material data input. Other than that, we have to give some guidelines for storage compatibility, instruction for personal protection and fire protection. All these parameter measurements, you need a lot of analytical power, a lot of analytical instruments to monitor the input controls and restricted substances. Now come to the important point, trends and new tech. It goes into two directions, trends and new technology, well as new tasks. You have to first fulfill the end users' requirements, brands or the people who use these products. We have to give some solutions for those trends. In the other hand, always it should be a sustainable solution. Now, talking about new sustainable solutions, other than restricted substance measurements, elimination of those emissions and waste water treatments and all that, those are now stale topics for the sustainability point of view. Circular economy concept is a new project which creates the circular economy concept to symbiosis between the textile and chemical industry. Starting from energy and material input, then goes to the production to get a product, distribute, and then it goes to the usage. After a usage, it goes to the disposal level. And after disposal, certain amount of things, majority of things goes to the waste, dumping waste or emission leakages. Now the current thinking to create some sustainable way to keep the things go back to the energy and material input. First of all, people think to reuse most of the apparels. It's already happening in the world. And longer use apparels design and intensifying usages and dematerialization also, because certain garments, they change into different other applications. Then remanufacturing and refurbishing also part of the recycling economy. But recycling, it's an interesting part. Processing of raw textile waste and mixtures, those are coming from silk gut protein, cellulases, polyester or polyamide fibers, into secondary raw materials for the chemical industry. Proteins can convert into adhesives to make wood panels. Cellulose extractions, the end point, convert into glucose or bioethanol. Those are the two energy sources for in a circular economic conditions. Polyester depolymerization, you can make the monomers like terephthalic or ethylene glycol. Again, you can use it for polymerization or in different stages. Polyamide also now depolymerization started and can yes. Now this recycle content commitments coming from leading brands. You can see the figures. It not only for the polyester and synthetic fibers, cotton also. Now reused garments. Few companies in the world, they started to do the sorting out yarns and give colored yarns as recycled yarn. Global plastic production and its fate. That also a very important thing as far as if we concern about the sustainable development of the apparels. The total, I am talking about the total plastic, but out of that, there is a fair bit of plastics involved in the apparel industry. From 1950 to 2015, 83,000 million tons of plastic, 8,300 million tons of plastic produced, and at the moment, 2,500 million tons in the usage. After that, you can see 5,800 million tons of plastics, either it goes to the discarded level or landfilling stages. Now I will show you exactly how it happens. Out of this 5,800, 4,600 million tons already discarded and 700 million tons incinerated, and about 500 tons still in the recycling process. If you see this chart, the most concerned part for the sustainability is here. 4,600 million, million tons, 4,600 million tons in the dumping yards. We should minimize this to get more sustainable textile solutions. This is not only the auxiliary part, but this is part of the synthesis part, how we are going to recycle this part. Now in textiles, actually 52% of the fibers are polyesters, 23% cotton, and about 6.4% man-made cotton fibers like rayons, and wool and feathers for 2%, and polyamide, polyacrylamide, and other fibers about 17%. You can see now the polyester amount is fairly bigger and a bigger chunk. Because of that, we have to handle the polyester much more with a more careful manner, how to do the recycling. Now these microplastics also another, I want to just touch this, either less than 0.5 centimeters or more than 0.5 centimeters. All these emissions day by day increasing, and it goes to our waterways. This will disturb the aquatic life very much. And this aquatic life disturbed from the microplastics, it will disturb the food cycle of the human beings also. To minimize all these things, we have to do the recycling. That's the only way we can utilize this synthetic fibers with minimum impact to the environment. Fortunately, now polyester, even in Sri Lanka, recycled polyester make very value-added garments. It's a huge achievement from our side, but in the meantime, in the entire world, you can see there is a growth every time for the PET bottles. PET bottle consumption every year, it's growing up by 3.2%. Convert this PET bottle into the polyester fiber and do the recycling. And now a lot of research work is going for converting the polyester with more effective way, like modified the surface with anionic components to give more fashion to the garment. With the recycled polyester, huge challenge for the auxiliary manufacturers as well as for the dye houses, because of breaking of the polymer chains, and certain other parameters also disturb the long chain polymer. The oligomer formation is comparatively high to the conventional normal polyester sources. The problem of oligomers can be very complex as there are different types of oligomers. To arrest these oligomers, we also develop one strong oligomer remover, which will help to create a more sustainable and very uniform level and disperse dyeing patterns. Again, the polyester is another energy consuming dyeing programs because the polyester nature of the polyester fiber, you have to use energy to open up the opportunity for dyeing, well as continuing the dyeing programs. Energy is wasting, like comparing with any other fiber. With all the new developments with the fibers, well as dye stuff, at least it should go to 115 to 120 minimum Celsius to achieve the dye. In our case, we develop one product which is having a very high leveling capabilities. You should increase the temperature in a very rapid pace. That means 5 gradient also you can use it. Normally half a gradient or 1 gradient is the ideal for polyester dyeing. 4 to 5 gradient without any problem you can achieve with this pill level HPL. It's excellent leveling agent. And on the other hand, after the dyeing, to achieve the fastnesses, normally you have to do a conventional reduction clearing. This reduction clearing also, conventional methods either used hydrous caustic or thiourea. Both of these auxiliaries are very harmful as for the concerns about the wastewater, because it will go up the wastewater BOD, COD levels to the maximum level. If we can, and not only that, these are working in a high alkali conditions. You all know polyester dyeing programs happening in pH somewhere around 4.5. And after that, you increase the pH to 9, 10 to get the reduction clearing. And again, you have to reduce it to the right pH level. All these things involve number of water baths. To avoid this, we create a mega clear PHCR. It's a reduction clearing agent with super efficiency, and it's par with hydrous caustic or thiourea. But it works the same dye bath pH like 4.5. Then you can eliminate about 2 to 3 water baths and continue the dyeing also. For the other fibers, like if you are using polyester cotton, you can continue the thing in the same bath. Coats, as a yarn manufacturer, they create a eco-regain range of 100% lyocell thread from a sustainable wood pulp. It's a very eco-friendly fiber and can recycle 100%. 100% biodegradable and compostable because of its cellulosic origin. There are some additional advantages also from this recyclable yarn. It's giving outstanding comfort and excellent elongation properties. Now we will come to the bottom part of the apparels. Yeah. 5.5 billion pairs of jeans produced worldwide. And for one particular jeans pair, we utilize 10,000 liters. It may be a question mark for you all, I know, but from the cotton plantation up to the finish of the fashion garment or jean, this much of 10,000 liters we spend. And not only that, during polyesters, I talk about polyesters after effects, but cotton also giving a lot of impact to the mankind. 16% insecticides and 6.8 herbicides used in the worldwide for cotton plantation. This 10,000 liters we have to minimize, at least not from the cotton plantation, but at least in the processor. We developed a biofading enzyme without water. It gives a big impact to the industry. Get the same abrasion and anti-backstaining properties without water and give the same fashion effects also. I'll go through fast because I also time also running out. Now another most important auxiliary in the fashion industry, especially for the wet processing people, potassium permanganate, to get special designs and special fashion effects from potassium permanganate. But from these pictograms, you can see the health and the environmental issues, how much can create from this potassium permanganate. For that, from 2020, lot of pressure groups, well as buyers and brands, they replace this permanganate from different other substitutes. Most of the substitutes also either very expensive or those are also not very health friendly products. We developed a product which is more towards the green environment. It's called the Greenox 120. It's a PP replacement 100% because achieve all the necessary requirements from this product with more environmental friendly and health friendly way. Now another very interesting process. At the moment, only very few plants they are trying out with this carbon dioxide dyeing. It's a very, very environmental friendly and sustainable solution for dyeing programs because this process not involve any water or chemicals. Only the dye stuff involved, and technology uses reclaim carbon dioxide as a dyeing medium. It's this process, carbon dioxide in the supercritical level, that means liquid and gas phase in between situation is the supercritical fluid. This supercritical fluid can penetrate into the fibers very rapidly, and in the meantime, the fibers can solene and plasticize. That means the penetration of the dye stuff, dye solubility also very much better compared with any of the other dispersing medias, and give very in-depth colors, vibrant colors, and 98% of the dye stuff move to the fabric. The other beauty of that, very much less energy used for this process. And after the dyeing, you don't need any washing or drying or anything like that. You just release the pressure for the carbon dioxide, it moves to the next chamber, and you can do the recycling of carbon dioxide and create again the supercritical fluid. This is an excellent process for sustainable dyeing, but unfortunately at the moment, because a lot of pressure involved in this process, a lot of controls in this machinery. Because of that, at the moment, this machine is very expensive. Few machines in Asia also, in China, Indonesia, and Taiwan. But if the production is much bigger or much more numbers coming out, then the price will also hopefully go down. Excellent solution for environmental friendly dyeing. The thing is, carbon dioxide, the critical point for supercritical fluid level is 31.1 Celsius. It's a unique for each and every gases to get the supercritical fluid temperature. And with the pressure, you can change the liquor density also, and you can make a lot of new developments also with this supercritical carbon dioxide dye. Now, I will come to another water wasting process. Entire world, actually 88% of the water goes for agricultural purpose. About 7%, 7 to 7.5% only goes to the industry. Out of that, about 1.5% for the textile industry. Out of that, about 40% goes for pre-treatment. Pre-treatment is a must for any new developments or apparel industry at the moment, because asking for different fashion colors, pale colors, all these new developments, bleaching also essential process. Conventionally, peroxide and caustic soda is key to the bleaching. because these two react and make peroxy ion. This peroxy ion can attack to the conjugated double bonds of a chromophore in the cotton outer layer stains. This will, if the chromophore conjugated double bond disturbed, means the color will disappear. That is called the bleaching action. But in the meantime, there is another way the peroxy ion can go and react. With the cotton, the oxy bond also can break with this peroxy ion. This will reduce the strength of the cotton, and tensile and bursting strength will also reduced. We developed a caprolactam molecule which can arrest the peroxy ion like this. Caprolactam molecule will arrest this peroxy and goes to the hydroxy bond. Opportunity will block because of the steric hindrance effect of the peroxy ion and the caprolactam molecule together will block this. Then only pathway to get the peroxy ion to react with the conjugated double bonds. The kinetics of those two reactions, then one kinetic will become 0 and the other one almost near to double. This advantage we can utilize to either reduce the temperature or reduce the process time or cut down the caustic peroxide levels to get a better environmental solution. Now you can see from this advanced booster for peroxy ion, either save energy or save process time or improve quality. Our product name called Turbo Bleach H3. It's a big impact to the environmental friendly solutions in the near future. Now again, we will go to the new dyeing trends. Actually, this cationable dyes is a very old dye stuff, and with natural fibers, well as with polyester dyes, cationable polyester dyes, it can give extremely quality dyeing programs. But the current day challenges with different types of fibers together in a fabric, acrylonitrile, cationable polyester, and polyamide together, then the basic dyes will not perform as expected of with cationable polyester level dye. We developed some molecules with thymine structures to retard the dyeing sequence and give a very uniform and level dyes for different fiber types in the same fabric. Another dyeing series is for natural dyes. It's ongoing development state development. Natural indigo made in bacterial fermentation tanks and work as an indigo dye. Certain microbes also create some colors from vegetable-based products. And plant leaves and petals, roots also used as natural products. Now, tea extracts also a very popular and successful natural dye substrate. I don't want to talk too much, but one thing to get the uniformity and the levelness and the fastness, we have to do a lot of developments as an auxiliary manufacturer to create more and more modians into this process. Now we developed another reactive dye stuff range. Actually, it's a polyfunctional reactive dyes with a very high fixation, and these fixation levels are extremely high comparing with dichlorothiazine or monofluorothiazines or FCPs. Those are old-fashioned high fixation dyes, but giving some adverse effects also as far as concerned for the levelness, and the energy consumption. These polyfunctional groups having inductive electron affinities towards the cellulosic charges, very much having a friendly affinity. Because of that high fixation in a very low energy levels. This is the beauty of this range. And because of that low temperature, it works with high fixation, and the wastewater discharges are minimal. And you can do the soaping at very low temperatures. 60 is the maximum. You can achieve all the fixation levels within that low temperature ranges. And the process also much speeder because the fixation levels are much faster. Another future development, it's a salt-free dyeing. Salt is a big headache at this moment, but anyway, salt storage and for sourcing of salt is a big problem. Nearly about 15 years back, salt-free dyeing started, but unfortunately what happened? The cationizing agents not properly dispersed along the fabric, certain unevenness started and ring dye formation. Because of that, light fastness issues also arises. We developed a cationizing system, uniformly distribute the charging densities along the fabric before you pass it into the dyeing. This is a huge achievement because the charge density control by using condensate amine product, which distributes and adjusts itself the charging densities in all over the fabric without any changes. For the light fastness issue also, this also only the ring formation, but the light fastness issue we address by developing a UV blocker for cotton fiber also. This UV blocker will take care about the UV damages coming to the dye stuff. This is having a very high exhaust rate. Because of that, it's more economical UV absorber for the cotton well as for the synthetic fibers. Clean Co also part of the developments with salt-free development, because the Co is free of dye stuff. In the fashion industry, you can do a lot of variations for the surface of the fiber and get the surface clean fabric, because of the inner core is very free of contaminants and dye stuff. Then there is another more recyclable solution for the auxiliary business. Now a lot of silicon end-of-life polymers are throwing away to the waste, like lot of things. Now the current biggest waste is coming from the vaccination doses, also sealed from a silicon thing. If it is not biologically contaminated, we can use it for recycling. End-of-life silicones can collect it and process and generate silicon oils and do the amido or any blocking silicone softeners, oils, and make it as a silicone softener textile, applied textile. This is an ongoing process. For polyester and cotton, you can reuse it also. We are considering to regenerate again and again this silicone chain to give a more sustainable solution for the finishing agents. Then we only talk about now more and more details about the dischargeable, restricted substances, toxics, wastewater dumping issues and all that. But United Nations, as far as concerned for the sustainability, they issued a goal with 17 objectives. If we are talking about auxiliaries and control emissions or restricted substances, toxics. But what will happen if the industry is not sustained and it's not moving in the right direction? We will lose job opportunities. Then only the UN gave a direction for 17 objects: poverty alleviation, zero hunger, good health, and all these 17 parameters were there. All actually the students or whoever comes for the buying officers, especially, you have to think in a different way. As a chemical manufacturer, we always think about how to eliminate whatever the toxics and toxins and eliminations. But other than that, entire community should think in a different way how to minimize these environmental impacts and social impacts from apparels. Then we have to come into a balanced situation. This is very important. This is my final actually message. As an auxiliary manufacturer, we should not damage earth. That is number one. But in the meantime, to sustain the business, we have to think differently. This is my short briefing about how a chemical manufacturing personnel think about the sustainability and what sort of developments we can do at the moment. There are so many other developments also in the pipeline, but unfortunately time restraint for me to talk about those. Thank you very much for giving this opportunity. Dinusha? Thank you so much.
Right, Mr. Dayantha. So you can stop sharing your screen. Thank you very much, Mr. Dayantha.
Thank you.
Detailed presentation, and it took us back to the stone age of the chemical industry and walked us through the whole cycle of textile chemical evolution, I think. And even you were able to take us through the future of the textile chemical industry as well, giving us some ideas and giving us directions on what to think about when you consider about the balance of the textile chemical industry as well as the sustainability. So we have few questions coming in. We already have few questions in here.
Yes, yes.
Right. I'll start with the latest question. What is your opinion on current sustainability targets? Are they really pushing for real sustainability?
Yes, already actually I discussed a little bit, because sustainable targets, you are talking about a chemical auxiliary manufacturer or as a whole?
Yes.
As an
Yeah,
industrial?
this is regarding the whole sustainability targets given by the zero discharge and the brands.
Yes, actually, a lot of things are already happening to control the restricted substances, emissions, and all that. That part, I think, a fair bit of ground covered, but we have to do a lot of things as far as concerned for monitoring. Now there are so many monitoring bodies. You also may be confused. Blue Science, Zero Discharge Platform, Scavira, all these people involved with the buyers and brands, and they decided different parameters, but at the end it will come to the same platform. What happened if as a manufacturer of chemicals or even a fabric or a garment manufacturer, you have to spend a lot of energy, time, and analytical power to give the answers for these people. This in our case, keeping whatever the manufactured substances for longer periods and do analysis, shelf life assessments, all these things for a one platform, it's okay, but with too many authorities, it will be a big ask or a challenge. Other than that, the people, the buyers, everybody, end users should think how to give a more sustainable solution. What I mentioned, control their apparel intake. One way, it will be bad for all our industry, but recyclable material to be used. All these things also should come into the picture much rapidly.
Right. So the what I understood is not only the pressure on the chemical manufacturers and chemical users, but everything else also has to be together to serve this real sustainability part.
Yes, yes.
Right.
Actually, it's
Okay.
a very good example. Now I can take it with this epidemic condition. The health authorities and whatever the control bodies can do the maximum, and they are the key personnel. Like that, in this scenario, chemical manufacturers have a major role, but the general public also having some sort of a responsibility. That's what I want to say.
Right. Okay. So the next question is, we can take another maximum two questions.
Yes.
I'll take your So your opinion on that we asked, and what is the biggest challenge for chemical suppliers from a sustainability perspective?
It's a huge challenge because sustainability is one arm of the entire business, but day by day ongoing challenges for the garments or the apparels to be developed with different type of fibers, different comfort zones, so many challenges. As a person involved in the fabric segment, there are so many challenges. And then if you put sustainability things and the new developments together, you have to utilize a lot of resources. And in the meantime, conventional things to eliminate from sustainable solutions, the chemical industry, a lot of resource-less situation. Because for the last 20, 30 years, most of the products, I will give a very good example, phosphonates. Now people are talking against the phosphonate-based products. To replace phosphate, there are other chemistries involved, but the capacities for those manufacturing, the intermediates or the basic raw materials, are very less. Because of that, if you try to switch on from phosphate chemistry to other one, the pricing is a huge challenge. Everybody can talk about phosphate-free environment, but in the other hand, the initial stage, now we are in the beginning of this era, lot of question marks for getting the right raw materials at the right pricing. I'm not saying cheapest one we should use to get the product, but the changing pace, we are facing huge challenges.
So from what I understood, I feel that the brands' sustainability goals and their price goals has to be on par. That is one of the major challenges you are facing at the moment.
We have to synchronize both ends, yeah. Pricing.
And we have two more questions. I'll take only one and I'll forward you again, and we will contact whoever asked the question and we'll give them the answers separately because we are running out of our planned timing. So someone is asking about, do we have a sustainable screen printing technology? Anything you have heard of?
Actually, there is one solution for sustainable screen printing, because that is the products, the binders, certain fixing agents and the finishing agents, all are cradle to cradle approved products. That means from one point to the other point, you can utilize and you can recycle it back to the normal state. Even the pigments are cradle to cradle, some high ranking. That is, I explain a little bit about this cradle to cradle business. They get a higher points for pigments also. That means that pigment also extract and reuse it. There is a current ongoing discussion for that sustainable solutions for screen printing.
Right. Okay. So with the time restrictions, so we will have to close the session today. I will hand over the session to Ms. Viturusha to make a note, the thanking note, and conclude the event. And thank you, everyone. Ms. Viturusha, stage is yours.
Thank you, Mr. Dinush. So very good evening to everyone. I'm Vitosha. I would like to thank our speaker, Mr. Dayantha De Silva, Managing Director of D Chemicals Pvt Ltd, for enlightening us with this knowledge today. So it was full of knowledge and interesting things. It gave deep insight into the topic and also revealed some interesting facts. The points where Mr. Dayantha told us about the circular economy and waterless, chemical-less dyeing process, and some developments and new trends take place in Sri Lanka were really informative. I'm pretty sure that the precious knowledge that Mr. Dayantha gave us will definitely help our audience. Once again, I would like to thank our speaker, Mr. Dayantha De Silva, to take out his busy schedule to grace the session. And a special thanks to Mr. Dinusha Somasiri, Head of Innovations and Development of Hayleys Fabrics Pvt Ltd, and our MUTA Executive Committee member to moderate this event and take it smoothly throughout our session. And I must thank the patrons of MUTA, Head of Department, Dr. Nandula Manasekara, the President of MUTA, Dr. Dayantha De Silva, the organizing team, Executive Committee of MUTA, and our media team for working for the past few days to make this webinar successful. At last, I extend my gratitude to all of our participants today for their active participation. Thank you, everyone, once again for making it a great success. Over to you, Dr. Dayantha.
Thank you, Mr. Dayantha, and thank you, Mr. Dinusha, and thank you, Ms. Viturusha, for everything. And thank you for all the participants. Okay.